Hello everyone. Welcome to the BalCCon talk about the BalCCon2k23 board. Please welcome Flo.
Thank you very much. So today I'm going to talk about your beloved CyberDeck. So with extensive preparation, of course, everything is going to run smoothly, so we'll see. Yeah, you may have seen the announcement for the badge for the CyberDeck, and so you might be aware that this was developed all in secrecy, and that ACID actually had to go and steal some of the designs. Now, luckily, you could get your own badge. If you didn't, you still can. Just go to the front desk, and you can transfer some money for a working electronic device. I would like to give you a little overview about how it came to be and what's actually the purpose of it. And because I know some of you just will fall asleep within the first 5 minutes or have something better to do and need to get a beer, that's what's the TLDR. So you have everything I'm going to tell in the talk, and you don't need to stick around if you don't want to. So first and foremost, your CyberDeck comes with a firmware. You can get the new firmware, or you should get the new firmware at the modding desk. If you haven't done so, that's for the conference. It's quite simplistic, but there might be a secret or not. And then, of course, it's good if you can find those secrets. That's a little game I'm going to explain in the end. There's also a developer challenge. I'm going to explain that in the end, so stick around if you're interested in that. So how did the idea come to be? It actually happened that I was chatting with Milos and Jelena, and we thought, you know, it's been a while since BalCCon had a badge, and we should do one. So we went and sketched up something, and you see the very first sketch where the idea was, let's take the logo and make something electronic. If you look at your badge, you know that's not how it played out, because there's way too many measurements in that drawing, and it keeps to lock up, and yeah, well, it was an idea, but that's what it was. What remained was the shape of the main board. So we went out and we did some more sketches. So on the left-hand side, you see what can we actually fit in a form factor that you can still hang around your neck, and actually there's other carry methods if you're very creative. That's not too big, but still features some sort of display. At the same time, we started to sketch out. You know, you see on the right-hand side, rough sketch. It was very clear we wanted to have some LED because everything's better with LEDs. And then also have a display. The first idea was to have an OLED display, simple text display. We skipped that then for something in between what you see on the left and what you see on the right. So that's that. So how to go forward? Now, bear in mind that's the very first batch I ever did. I had absolutely no experience in what to do. So that means you first start reading data sheets. And that's when you wish you would have paid better attention in school, because it rings familiar, but honestly you don't understand it. So that's the thing. That's when you remember that you actually would solder some pre-made modules of quadcopters some 15 years ago. Yes, that tells something about my age. And you just wish, you would have been more careful and learned more. So, but the thing is, one thing that I found super useful is really taking a pencil, taking a piece of paper, and actually sketching out circuits. Also, we have this nice thing called the internet, so you're likely going to find someone that has done something similar before. And that's where the problem starts. Similar is not same. You need to do something. Then, of course, one thing that you will quickly discover is that the power supply is at the heart of any electronic device. And so you see in the picture, we did some measurements for the display. Now, good news is the display doesn't use a lot of power. You could actually power it with the AA battery shown in the image before. Bad news is if you want RGB LEDs, and if you don't want to limit the brightness in software, because blinding yourself because of a wrong line of code is fun, yeah, you need a lot of power, because they draw up to 60 milliamps one piece. You have 6, that's 360 milliamps. Take the chip, we decided for an ESP32, add the Wi-Fi, add some Bluetooth, add another 500 milliamps. You round up approximately 1 amp. That's not going to be delivered by your AA battery. So LiPo is the right thing to go, right? Now, we don't like your home being on fire, so that's why we then settled with LiFePO, which is much safer and should work fine. So next step is, because remember, I have no idea what I do, is actually to prototype some of the parts. So on the right-hand side, you see the power supply, the first draft of the power supply. It was clear we need a 3.3 volt rail for the ESP32 and most of the electronics, and we need a 5 volt rail for the LEDs. Yes, you can power them by 3.3 volt, but it's not correct, and that's why we decided not to do it. So we need 2 power planes. We tested that, and luckily it worked, unless it didn't, but I'll talk about that later. On the left-hand side, you see the controller. So that's your fancy buttons. Now, we had a little discussion, so I was very lucky that actually Mladen and Jelena and Voja as well helped me to think about these things and do some debugging and so on. And we had a discussion where I think Mladen's point, and maybe I do him unjust, but he's not here, so he can't defend himself, was like, yeah, you can debounce switches in software. What debouncing is, if you push a button, it's actually not making a solid connection from the point you push. It's moving up and down a little, and you see the flickering. Honestly, I'm a software person, but I don't like fixing hardware's fault in software. So we did proper debouncing of the switches, which adds a couple of caps. And yeah, it's cheap, honestly. Everyone always arguments with the price. It's not the price, it's the routing that becomes more difficult. So that's why people are lazy. Then also do some calculations. So you need to push power through your traces. Calculate how wide they have to be. Because if you don't, you're going to regret it later. So the modules were made. Next was the schematic. Now the schematic is the fun and easy part, and it becomes more fun and easier if you add wine and food. So that was what my desk would look like coming home from work late in the evening and doing another session. It's pretty straightforward. I will talk a little bit more about the schematics. I will put them online, so everything will be put online. You can build your own if you want. You can also just get one here. So after the schematic comes routing. That's where the fun starts. I decided for a 4-layer board because honestly there's no reason to do a 2-layer board. It's not much more expensive to have 4 layers. It's a way better design because it can put the power planes in the middle and you can route the signals on the outside. I made a mistake, it's still in your badge. I learned as I went, so I have a power and a ground plane. I learned it's actually absolutely unnecessary. You can just have 2 power planes, basically. It depends a little bit on the parameters and what you try to do with it. So you have to route it out. You have to make sure your signals do not disturb each other. And you also need to make sure that your signal, it has, so we're talking physics here. So a signal has a time it needs to travel through a copper trace. And that's the wiggling you see up there. That's basically to make the traces the same length. In that area, it would not be necessary. Let me be completely honest with you, it works without. But again, we should do it properly because we also want to learn, right? So that's the serial connection, and I will talk about that in a little bit. So we had the design finalized, had a nice 3D model. Everything looked good. So let's manufacture. So we got the first board, and a couple of weeks later the chips. That was during a time of chip shortage, by the way. That was, redesigning the thing because the chip you actually planned is no longer available. That just became a reality. And that's actually the very first batch made. I have this fancy thing. Does it work? Can you turn on the camera? So that's all hand soldered. That's when I decided it's not worth it. I'm gonna order it pre-assembled because half a day soldering by hand, SMD components as little as 08, 05. It's still doable. It's not that difficult, but it sucks. Yeah, what you see here is, of course, your prototype doesn't work. That's the definition of prototype. So you have to add some wires. And we can go back on the slide. So Jelena, I want you to have this one. It's the very first I ever made, but it's for BalCon. You're welcome. So, yeah, the first thing that didn't work was the serial programmer. I used a CH340 chip. Turns out this thing does not like disturb reasons. This thing wants to be nice and easy for its own. So first troubleshooting was, bridge the power supply, because I made a mistake with the power supply. The idea was I actually feed it from a separate voltage regulator. So this thing is not powered when running on battery. This thing is only powered when you plug it in. That doesn't work because it doesn't have the same ground plane and it hates that. Even though theoretically the ground planes adjust when you plug it in. It doesn't like that. It's not working. So what to do? I mean, you could order a new prototype that's going to cost you money and has long delivery times. So after playing around with it for a couple of days, you desolder the whole mess, you hook in a known working programmer, and you can at least flash the thing. Good, so you see the display is not yet mounted. So that's the other thing. You don't want to add sources of error before testing your stuff. So yeah, that's with the voltage regulator. Don't do that. Just hook it up to the power plane of your batch. So the next one was the LEDs were not working. Remember, we have the LEDs. We need to actually get the voltage from a 5-volt plane. And then we also need to shift the levels because you have to put out the signal. It's the WS2815 LEDs. So they are chained in series, as you see on the top right. And you send through a signal, and every LED basically takes the first part, and uses that to decide how the values of R, G, and B, red, green, and blue, need to be displayed. And then the rest is passed on. But your ESP32 runs on 3.3 volts, so it's going to output a 3.3 volt signal. Now again, your LEDs will recognize the 3.3 volt signal, but it's not the right thing to do. It's better to translate that in a 5-volt signal, and there's chips to do that. Problem is, you should create a proper footprint, and you should wire them correctly. That's why you see there, it's working with the wire that bridges some of the gaps. That's just things you learn. And because they are hard to troubleshoot, absolutely get an oscilloscope. It's going to save your life, even just to see if the bits are actually coming out of the chip proper. Yeah, so it's working. That's actually a picture from Laden when he was on a holiday in Turkey testing if it works. So that was good news. It works for him as well. So the first batch did not have a switch to turn it off. Yours does. So you can turn it off, turn it on, right? We decided it's not nice to have a batch that you can't turn off because it will get on your nerves eventually, and taking out the battery, it's quite hard. It's not enjoyable. Now, one thing that happened is, the first thing actually that happened is, When drawing more than 1 amp of power, it would take a dive. The voltage would drop. Now that was an easy fix. That was basically just a capacitor that wasn't big enough, and an inductor that was not built for this amount of current. The second was when you flip that switch, and that's what you see in the oscilloscope here. Actually, the TP5000 chip, that's the one here in bright orange, became very hot. Hot enough to burn. Now, this chip has overheating protection. It shouldn't do that, but it does. To date, we still have no idea why it does that. I have a suspicion. I found one of the diodes conducting in reverse. I have no idea why it does. I'm very happy that other people like Mladen and Voya who do that professionally have no idea why. So that makes me feel good, while it doesn't solve the problem. We'll keep on it. I developed a special board where we can switch in and out parts. The interesting thing is it does that even if we just use the power supply. And maybe it's just, we will settle for another chip. But that was an easy fix. So the initial power supply design was that when you plug in your batch, it would power the charging circuit for the battery, but it would also power the batch. And when you plug it out, it would be powered from the battery. Now, you will find out that when you don't have the battery in your batch, it does not work. It does brown out. That's because now it's in series. That's how all the mobile phones do it. There might be a reason for that. So it works now, you just need to have your battery in there. That also means if your battery is completely drained empty, charge it for 30 seconds before powering it back on. But it works and it doesn't overheat, which I consider a win. So now the next thing. We had a discussion, we have plenty of ideas for batch challenges and things. So the good news is, if you purchase the batch, we plan to do more things with it next year and the year after, and maybe even after that. So the idea is, we didn't like the idea of having a batch, you hack it a little bit, you take it home, and then you hang it on your wall and you never remove it again. So the idea is, it's more a development framework you can use if we want to make it easier for people to actually make it your own. And because we have a cyberpunk setting, and everyone knows you have to make it your own. You can't just buy it, right? Built is better than bought. So I developed the framework. You still have to write C++. You can do it like I do. You can write bad C++ because the standard changed over the last 15 years, and I had no idea how. And you can write C++ just as you write C. That's still working. But you need to have C++ because the graphics library we use uses C++. That said, you can skip the framework completely and just use MicroPython or Rust or whatever you fancy. It's an ESP32, the schematic's up there. Feel free to do whatever you want. Writing the framework, one thing comes in handy, and you might have seen it or you might have not. We can quickly show it on the camera. So up here, you might see it or not. If you have a badge, you can take a look where my finger is. There is a port, that's a JTAG debug port. So you can hook up JTAG, you can debug it. It's working. We can go back, thank you. Because we wanted to make it easy for you to develop your own stuff. And yeah, you might use it for the challenges or not. So let's talk about make it your own. So first, as I said, we want you to program, we want you to play with it, we want you to develop add-ons. And we will have workshops at the modding station tomorrow. Because we're lazy, we didn't put up any specific times, just drop in, and if there are enough people, we will do that, right? And if we're there, and if you're not, track us down. That's part of the challenge. You see here the GitLab with the documentation. It's up there. You can also find the article on Hackaday. We published that because we wanted to participate in the CyberDeck challenge, and that was before the conference. So you can find it there. Just keep in mind, I'm going to update the repository with some recent developments. They will not break changes, but they will make development a little bit easier. I plan to do it tonight. Honestly, I don't think I will. I will do it tomorrow. You still can use it. We will put up the schematics. That's actually the main page of the schematic. You see the ESP32. Let's not get into details. I want to quickly rush through in the next 2-3 minutes, and then we have time for questions. So we have inputs, greatly inspired by the only one controller worth mentioning, the NES controller. So basically, it's just the shift register that takes your inputs and you probe the shift register. So if your controls are a little bit bulky and they are better in the Snake game, that's because I had a better strategy in the Snake game for querying the controller than in the menu. Again, easily fixable. I didn't have time. That's a circuit. I talked about that, hardware debouncing. You don't have to worry about debouncing the switches. You can just go and program the thing. There's actually a controller. You can capture the input, so that reads the shift register. But because that makes it bulky, you can also sample it. That means if you add buttons later, it will just add up and give you all the buttons. You can query it. The buttons are left, right, up, down, A, B, X, Y. They're not labeled on the board because that would not be fun. So then we have the LEDs. I talked about those. That's the in-series. That's the level shifter. So I'm going to skip over that. So one thing is your batch or the framework is built upon ESP-IDF and upon FreeRTOS, which is a real-time operating system which gives us concurrency. And it wouldn't be nice to flash the batches and then display something on the display and then maybe enter input. So I programmed the driver for driving your LEDs completely concurrently. You can schedule a pattern and let run the pattern, or you can control the LEDs individually. There's some hints how to do it. Again, come to the table. We'll explain it to you. Shitty add-on, but plus, because who wants to have a normal shitty add-on? I told you I like 5-volt power rails for LEDs, so we added 5 volts and we have 3.3 volts. The rest is compatible. So just watch if you have an add-on. Be careful how to plug it in, because otherwise you fry it, but you're adults, you can do that. It's GPIO, so it's easy to program. That's the demo board I forgot at home, otherwise I could show it to you, but that's just blinking some LEDs. But you can hook up sensors. The idea is to make some additional board stuff. It's an iSquare S bus. You can use it for whatever. Console. That's the important one. So I talked about the serial console and how we fixed it. So the nice thing is it has an auto programmer. So you plug in your cable, you set up your dev environment, you program it. No button needs pushing, right? That's good, that works. What doesn't work, unfortunately, is when you connect to your batch through the serial console using your favorite terminal. You have to restart the batch when you're connected, because the terminal will try to sense whether your terminal is ANSI capable or not. And if it doesn't answer, it will say, oh, there's no terminal, I'll do nothing. That's a bug. First one to fix it gets a beer. So yeah, that's more about the controller. Display, very simple circuit. It's a ST735 board. I'm using GFX library of Honey the Code Witch. Never met the person, but it's an awesome person fixing stuff very, very fast. We were in a lot of exchange because with everything I did, I hit a couple of bugs. It's great working with someone in the open source scene like that. I highly appreciate it. It's great code. It forces me to use C++ and learn modern C++, like 17 standards. Some would say that's not the modern one, but still. The driver for the display is based on the driver by Bodmer, which is mostly for Arduino. I don't like Arduino for personal reasons. No real reason. Use it if you like it. I don't. So we adapted that driver. There's still no buffering in there, so that's something to do. If you are interested in that kind of things, come to me. I have some ideas how to do it, just didn't have the time. I developed a library that allows you to build menus easily and to execute items on it. It's actually using inheritance quite a lot, increases your code base, but you've got 16 megabits of RAM, you've got 8 megabytes of PS RAM, so there's plenty of it. Pixel art. So that's my first pixel art I've ever done. I'm not good at art, but at least it looks like something. So if you start a game, you will recognize that. Again, there's more information on the Hackaday page. More information to come. Cases, there is a 3D printed case that you can download and print on your own. Unfortunately, we don't have a printer here. That's another one where I printed some nice, I don't know how to even describe them, but they will amplify the light and it looks nice. So feel free, if you're into 3D printing, add something to it. Now let me briefly talk about the challenges. So one, the exploration challenge. So as I said, ACID find some things that it reported to me. Director, the name comes from Jelena, that's not my invention. She calls me like that since years. So, find it out. Some people were already trying to score, so I give you another hint. The score is actually calculated by the base score, which I'm not telling you what it is, but the multiplier, and the multiplier is actually 100 and decreases by 5% every move. So that should help you or not. The first one to bring the final information to the desk will win a black badge. Second challenge. Fix the bug in the console driver, because I really care about that one. Rewrite the LED driver to support the new RMT driver of ESP-IDF. Port Doom on the badge, it's doable. I selected the ESP chip that it can be done. Clone any classic game or make it your own or do something really cool. Show up at the closing ceremony, demonstrate your project. The ones with most applause gets a black badge. Now what is the black badge about? That's a black badge. There are 5 in existence currently. There might be more in the future. So you can win one. It won't get you free entry. I'm sorry, we're not copying that model, but it will give you 5 free drinks at the next BalCCon and every BalCCon coming. So if you bring your black badge, 5 free drinks. And maybe even some gatherings, or we don't know yet. So yeah, it earns you fame. And with that, questions. I think we have 3 minutes left or so.
Are there any questions?
That's good. Yeah, there's one.
So I brought my badge and I was too lazy today to come to the desk. So I thought, maybe I can upload the new firmware myself. But I tried looking for it, but I cannot find it easily compiled, so I can just use ESP tool to upload it. Is it somewhere online?
So yeah, it's on the GitLab actually. So
the binary, because I'm too lazy.
the binary for the firmware.
I'm really lazy.
No, that would be too easy.
Yes. That would be compatible with me.
I will release it after the conference, but it would make it too easy.
Oh, okay, sorry.
But you can get the framework, so that's basically how you get the framework.
Yeah, I have that already,
And
trying to fix your console issue.
Yeah. I mean, it's already easy if you know how to do it, but we don't want to make it too easy. One over there?
Hi. You said you wasn't experienced with that surface, and I'm curious how much time you spent to make what you made.
So that's a question I can't really answer. So we had the idea, I think, 3 years ago, 2.5 years ago. I just started before working with the modules. You can get easily ESP modules. I did an irrigation system like probably everyone did somewhere back then. And then it was, sometimes I had more time, sometimes I didn't. I usually would spend 2 weeks in my summer holiday to focus on it. And otherwise I would work on it in the evening if I had time. It was a lot of work. It's not an easy or little task if you're as inexperienced as I am, but it's absolutely doable. And it depends a bit on how much you can invest. The most important thing is don't worry if you make mistakes. Don't worry if you fry things. The Magic Smokes helps you to get better. Just try. And start simple. So the badge that you hold in your hand started with these simple modules I showed. They're also on my GitLab repository, and just start with that and then build up in complexity. It's all modular, just like software.
Any more questions?
Good.
Thank you, everyone.
I think we're done. Thank you.